right, we're going to do a second day of arcs and chords. We're going to continue with some of the same questions you guys had last night, but we're also going to add to it uh, inscribing within a circle triangles and quadrilaterals and look at some properties that go with those. Okay, so the first idea here is inscribed polygons. And inscribed means that the polygon is contained within the circle. And specifically, what it means is the vertices of the polygon are points that lie on the circle. Okay, not every polygon can be inscribed in a circle. It's got to meet a certain requirement and have certain characteristics for that to happen. Uh, Triangles and quadrilaterals that can be inscribed within a circle do have some special properties, and these are the properties we're going to look at today. Okay, so the first one here we have theorem 10.9, and what it says is that an inscribed triangle of a triangle, excuse me, an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if it is a right angle. So your if and only if means it's biconditional, which means the hypothesis and conclusion can be interchanged and it still is a true statement. Basically, what it's saying here is if you look down at the diagram, point G, well, first of all, let's talk about triangle FHG. That is inscribed because the vertices of the triangle are all points on the circle. And second of all, you notice that angle G is a inscribed angle. Okay. And if it's an inscribed angle, that means that the arc that it intercepts, it is half of the arc that it intercepts. So, here's angle G. It's intercepting here at FH, which is a diameter. This arc is 180 degrees. So that means this angle is 90. And you actually kind of did some of these yesterday. Okay. But now we have a theorem that kind of sums that up. So basically, what this says is two things. If I know that FJH is a semicircle, then inscribed angle G has got to be 90 degrees because the inscribed angle is half of the arc it intercepts. And so what you look at here is you immediately see FH is a diameter. If FH is a diameter, then that's going to be a 90-degree angle. Okay. And then the inverse of this, if angle G is 90, if that's a 90-degree inscribed angle, that means that it's that where points hit the circle, that's got to be a diameter. Okay, that's got to be a diameter, and then this has got to be a semicircle. Now, these are all facts you can get without necessarily having to know this theorem because you understand an inscribed angle is half the arc it intercepts. It just kind of brings to your attention, looking for diameters and inscribed angles. It kind of helps put it all together. So let's look at an example question of this. They're asking us to find the measure of angle K. So this is an inscribed angle K. Okay, within this inscribed triangle in the circle. So immediately what we should see is that angle L has got to be 90 degrees. Okay, it's got to be 90 degrees. It's an inscribed angle whose endpoints hit at a diameter. We know that this creates a semicircle, which is 180 degrees. This angle is half of the arc it intercepts. L's got to be 90. We know that. All right. We also know that using the triangle sum theorem, these three angles have to add up to 90. In any triangle, the three angles have to add up to 90. And that's what's going to allow us to find angle K. Now, there is another theorem out there, if you remember way back when, that said in a right triangle, the two acute angles have to be complementary. So we could have just written this as, angle K plus angle M equals 90 and gotten the same result, which happens naturally if you just do it this way as well. But just want to throw that out there in case you remembered it. All right, so here we go. Angle K is 5x minus 4. Angle M is 8x minus 10. Angle L is 90. We're going to set it equal to 180. Triangle sum theorem. Okay, combine some like terms. Subtract our 76, divide by 13, and we get x equals 8. Just remember in all these questions, you got to make sure you answer what they're asking. They want you to find angle K. So we got one more step here. Angle K is 5 times x minus 4. X is 8. 5 times 8 minus 4 is 36. So angle K is 36 degrees. Now, a great follow-up question to this would have been to ask you what arc measure ML is. Okay, remember an angle is half of the arc it intercepts. So if angle K here is 36 degrees, arc ML would be 72 degrees. Okay. So there's just other questions that can be mixed into these, that can be beneficial. So just keep that one in mind. Okay. The next one we have, now we're going to start looking at a theorem that deals with inscribed quadrilaterals. A lot of different triangles, including right triangles, can be inscribed in a circle. However, only a certain type of quadrilateral can be inscribed in a circle. And this is what the theorem 1010 talks about. Basically, it says this: if there exists a quadrilateral that can be inscribed in a circle, then its opposite angles have to be supplementary. Both pairs of opposite angles. It's kind of interesting when you look at it. Okay, so here is our circle, obviously circle A, and here's our inscribed quadrilateral L K L M N, I guess. KLMN, yeah, KLMN. All right, and uh, if you look at, let's say, inscribed angle M intersects LN, this arc LN, and inscribed angle K intercepts the rest of the circle. Okay, so together, inscribed angle M and inscribed angle K intersect the whole circle, which is 360. And since their angles are half the measure, they got to be 180. L and K do the same thing. If you look at angle N, L and N, excuse me, do the same thing. If you look at angle N, it intercepts arc KLM. Angle L, inscribed angle L, intersects the rest of the circle. So together they intersect the whole circle. So these two got to be 180. So that's kind of unique to this quadrilateral that's been inscribed inside this circle. So here it says, if angle KLMN is inscribed in circle A, then we know two things. We know that angle L and angle N have to be supplementary. They have to add up to 180. And angle K and angle M have to add up to 180. So both pairs of opposite angles have to be supplementary by the nature and how they intercept the circle. Okay? So that's the one theorem we really work with an inscribed quadrilateral. So let's look at an example here. So it says Luke is creating stained glass ornaments. The ornament shown uses a quadrilateral inscribed as a circle. So they're looking at this, kind of looks like a trapezoid. I don't think it is, but there's a little trapezoid looking shape right here. And since I'm colorblind, I'm going to say it looks like kind of yellow. All right. We're not worried about this other one over here, which would be a triangle. We're not worried about that. We're just worried about this one. Okay. Now, by the way, we're trying to find angle F, this one right here, and we're trying to find angle G to measure those angles. Okay. Because it is inscribed, DEFG is an inscribed quadrilateral, right? F is on the circle, E is on the circle, D is on the circle, G is on the circle, so it's inscribed. We know that both pairs of opposite angles have to equal 180. So the way we're going to go about it is we're going to do each one separately. F and D are opposite angles. So those two have to add up to 180. Okay, so 3y plus 4 plus 5y plus 16 equals 180. Those are those opposite angles. Okay, 8y plus 20 is 180. Subtract our 20. Divide by our 8, and y is 20. Okay, again, make sure you finish the question. They asked for angle F, not for y. So finding y lets us get angle F. We know angle F is, go back up here, 3 times y plus 4. So that's 3 times 20 plus 4. So angle F is 64. You could find angle D by plugging in 8 here as well. Or you could do 64 minus 180 to find angle D. So that gives us these two angles. Okay, we're also asked to find angle G. So we know that those opposite angles, G and E, have to equal 180. So x minus 4 plus 3x minus 16 equals 180, opposite angles. Okay, combine our like terms. 4x minus 20 is 180. Add 20, divide by 4, x is 50. So that's great, but they ask us to find angle G. Finding x allows us to do that. All right, angle G is 50 minus 4, which is 46. So now we found F and G inside this inscribed quadrilateral. All right, so we're going to add a couple of those types of questions uh, to your homework tonight. That should say 10-4. Sorry about that. And that should not say that, but that's what happens. Keep doing this stuff. All right. So, anyways, I'll let you get started on your homework.